Good morning, students. Today we are going to discuss about isotope, isobar and isotones. So before that we should learn atomic number and mass number. Atomic number means total number of protons and electrons, isn't it? Mass number denoted by the letter A. It means total number of protons and neutrons present in the nucleus of atom, that is called as nucleons, isn't it? So an atom depends upon atom totally depends upon nucleus for the atoms. Okay, so isotopes means is same element, they have same atomic number but different in mass number. Here you can see the example: carbon, 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 all they have same atomic number but they differ in mass number. This difference is due to the presence of extra nucleus 6, 7, 8. They have same number of proton, electron and neutrons, but they have same number of protons and electrons, but their neutron levels are changed. Since they have same element, they have some dissimilarity, but their chemical properties will not change because all they have same atomic number 666. Okay, and two types of isotopes are there. One is stable isotopes, next one unstable isotopes. When there is more excess of neutrons, the atoms cannot hold the electrons. Due to that, it become unstable and they become radioactive elements. Some of the examples are uranium-235, uranium-238, iodine-131, cobalt-16, carbon-13, carbon-14, and they also have more medical uses. Okay, they have more uses. Isotopes have more uses, which is used in different technologies, different categories. We are using these isotopes medically, for treating disease. Okay, for treating cancer, for identification of several diseases. So they play important roles. What? Radioactive isotopes. Okay, so what are isotopes? Atoms of the same element have same atomic number and differ in mass number. The difference is due to the presence of excess neutrons, so their chemical properties will not be changed. Two types of isotopes. One is stable isotopes, next one is unstable isotopes. Unstable means due to the presence of extra neutrons, they become radioactive elements. Okay, the next one, isobar. Isobar means two different category of elements but they have same similarities. Here you can see two different types of elements: neon and sodium, argon and krypton, argon and calcium. These are different categories of elements, isn't it? That is neon, a noble gas and metal, sodium, argon, noble gas and krypton, metal, argon, noble gas and calcium, isn't it? Metal. So these different elements but they have some similarities. What similarity you can found here? They have same mass number and have different atomic number. So that type of elements are called as isobar. Atoms of different elements, they have same mass number but different atomic number, means we will call that as isobar. Okay, see the examples, you can clear from this. Okay, students. Okay, isotopes means same element but their mass numbers are different. Here, different element, they have same mass number. Just opposite to that of isotope is isobar. It is very easy to learn for you also. Okay, isotopes only has two types: stable and unstable. Okay, wow. Unstable isotopes play important role in medical field for diagnosing disease, for treating disease, and various field. They are using what? Radioactive isotopes. Okay, uranium, they are used in nuclear reactors, cobalt-60 for the treatment of cancer, iodine-1 for the treatment of goiter. So more uses are there. Till they become stable, they emit ions. The last one is isotones. Here also two different elements, two different categories, but they have different atomic number, different mass number, but they have equal number of neutrons. Okay, students, proton value say proton different, electron different, but neutron value is same, 6, 6. Boron, carbon, two different elements with a different mass number, different atomic number, but they have equal number of neutrons, hence they are called as isotones. Similarly here, see these two examples. From this you can understand what is isotones. Okay, so isotope, isobar, isotones. Have you understood? It is easy to follow, I think so. The next one is laws of chemical combination. Next we are going to learn laws of chemical combination. So we know that atoms combines with each other or elements combines with each other to produce different types of compounds. Okay, all these chemical reactions are governed by certain rules or laws that is given under heading laws of chemical combination. Laws of chemical combination. So whenever the elements combines with each other, all the reactions begin. There is a certain rules for these reactions. They all comes under categories of laws of chemical combination. We have 5 laws. One is law. We have totally 5 laws. Okay, all the chemical reactions are based on these 5 laws. One is law of conservation of mass, law of definite proportion, law of multiple proportion, law of reciprocal proportion, and law of Gay-Lussac's law. Okay, students. So 5 are there given in a book, but I hope that 8th standard itself you already studied too. So we are going to learn law of multiple proportions. So now we are going to learn multiple proportion once again. For isotope, isobar, isotones, I hope you understood. Next one, law of chemical combination. Whenever elements combine, they will always combine under certain rules. That rules and regulations only given under heading laws of chemical combination. All the chemical reactions that you study in chemistry, behind this, these laws will be there. Any one of the law is applicable. Okay. So law of conservation of mass, law of constant proportion, law of multiple proportion, and law of reciprocal proportion, Gay-Lussac's. In our chapter, we are going to discuss last 3, that is law of multiple proportion, law of reciprocal proportion, and Gay-Lussac's law. So law of multiple proportion, what it states? It states that when 2 elements combine, it can produce more than one compound, AB and AB1. Okay, wow. A and B are 2 elements. They are combining. Okay, and to produce what? They are producing more than one compound, AB1 and AB2. So, in this, any one of the compound will have fixed mass, either A or B. Here, A has fixed mass, which combines separately with B in different proportion. And this law was proposed by John Dalton. This law was proposed by whom? John Dalton in the year 1804. Students, law of multiple proportion. Who proposed this law? John Dalton in the year 1804. Okay. By the examples, you can understood that. Here, 2 elements, carbon and oxygen. 2 elements, carbon and oxygen is combining to produce carbon monoxide and carbon dioxide. Okay, AB carbon monoxide, AB1 carbon dioxide. In both these, the mass of the A is fixed one. The mass of the carbon is fixed one, which combine with the B separately in different proportion. And they produce, always when you take the ratio, they give a symbol ratio. Always they combine in symbol ratio. See, carbon combines with oxygen to form carbon monoxide. Carbon combines with oxygen to form carbon dioxide. Okay, in both cases, the mass of the carbon is fixed, which combine with B separately to produce symbol ratio. This is another example. Sulfur combines with oxygen to form sulfur dioxide. Here AB sulfur dioxide, AB1 sulfur trioxide. See, sulfur. Here both the mass of the A is fixed, which combines with the B separately to form a symbol ratio 2:2. If we take the ratio, that is 32 divided by 48, it's a symbol ratio which combines with the fixed mass of A to produce 2 compounds, SO2 and SO3. SO2 and SO3. Have you understood, students? So, 2 topics we discussed today. What are they? Isotope, isobar, isotone, and for one of the law also we discussed. Since from Monday, you are going to write the class test, isn't it? So for that, the test question is atomic structure. Okay, students, the present lesson only, what I am teaching now. Okay, 1 or 2 topics only left, only 2 laws are left. Remaining everything how to learn for the this month exam portion. Okay, since I did not give the evaluation part, now I am going to dictate the evaluation part. And the last class I said I will explain how to write the electronic configuration for higher elements. Since your exam is coming on, I have to dictate the answer for you, isn't it? So take your books and we can complete the evaluation part. Now I'm going to show in the video. See that and mark it everything on your book. Okay, students, and learn well and write the exam well. Okay, now you take your books and mark. And next class, coming Thursday, after that, coming Thursday, if I will explain how to write the electronic configuration for the higher elements. Students, please mark along with me. First one, this is the answer. Second one, isotope. Third one, protons and neutrons. Please look at this and dictate, just to mark it on your textbooks. This is the answer for fourth one. Proton 35, electron 35, 80 minus 35. So this is the answer. The electronic configuration is 2, 8, 8, 1. Okay. Check the next page. This is the answer for true or false. Check down, please. Here 8, isn't it? K is equal to 2, L is equal to 8, but here given 10, so cut it and write 8. The remaining here, size of the orbit is small, isn't it? When it is move away from the nucleus, energy level goes on increasing. So near to the nucleus, smaller orbit is the K, the energy level also less. Here you write different atomic number, here write same atomic number, okay? Okay. The next one is fill up the blanks. Calcium and argon we studied now. Just now we studied now. It is an example for isobar. Total number of electrons is given by the formula 2n square. Isn't it? N is the quantum number. N is equal to 1. N is equal to like that. That's formula. Niels-Bohr model we studied. And uranium-235. It is a unstable isotope. Uranium which emit it's a radioactive isotopes and it is used in nuclear reactors. Here neutron 7 minus 3. The value is 4. The valence of argon is 0. Always you remember for noble gas. For noble gas the valence will be 0 because you might study, isn't it? They never take part in chemical reactions because already they are stable. All the noble gas the outer shell has is totally filled with 8 electrons, so there no need to gain or lose electron, hence the valence will be always 0 for noble gas. Next one, match the following. Dalton, first atomic theory he only proposed. Chadwick, you know, is a discovery of neutrons. Rutherford, what is that? Discovery of nucleus. Niels-Bohr's hydrogen atomic model like a solar system. He only explained that what we studied is in circular orbit, important question. But it is only applicable for what? Smaller atoms, isn't it? And students, this is a homework. Don't look this. You complete Roman number 5 as a homework. Okay, Roman number 5 is a homework. I hope you all understood. If you understood, the name of the element I will give later. Before that, the mass number, atomic number, that and all you know to find out. Now do it. Next one, answer very briefly. Answer very briefly. See students, first one beryllium. K, that is total atomic number is 4. So K should is equal to L is equal to 2. So beryllium. Next one, electronic configuration for K 19, chlorine 17. This is the atomic number. First one 2, 8, 1. Next one 2, 8, 7. The next one, third question. It is on page number 127. It is on page number 127. Okay. One tabular column is given in the book. You take page number 127. Okay. Take page number 127. It is given here. Mark this question. Third one. Roman number 6. Third one. This is the answer. Okay. The next one answer, fourth one, K is equal to L is equal to 8, M is equal to 18. We know K, 2n square formula, K is equal to L is equal to M. Okay, just write. N is equal to 132. Here it is not asked, so just written like that. What is the same about the electron structure? Lithium, sodium and potassium have one electron in outermost shell right here. What is the similarity in lithium, sodium? If you write electronic configuration, the last shell all will have one electron. Okay. So sodium, potassium, lithium, what is the similarity means? Have one electron, have or not have one electron. Have one electron in the outermost shell. Here, right? Have two electrons in the outermost shell. Have one electrons in the outermost shell. B, you write have two electrons in the outermost shell. If you write the electronic configuration, outer shell ends with 2 electrons. Okay. See here, Roman number 7. I will give the answer later for you. Here, why do chlorine 35 have the same chemical properties in respect to do these atoms differ? Because they are isotopes. Okay. So these two I will give the answer later. For the exam you leave it. This one already we marked page number 131, isn't it? Already page number 131 it is given here. These two diagram, very important diagram, study and learn. Okay, these two diagrams you should write for this. That is atomic structure of phosphorus and atomic structure of sulfur. The next one, calculate the number of neutrons, protons, electron, atomic number 3, mass number 7. First one, you write, calculate the neutrons and protons for this. Okay. So, how you will write here, in here to that question, you write here, atomic number 3. So, what is the proton value? 3. Proton value 3, electron value 3, neutrons what? Mass number 7. 7 minus 3, 4. Isn't it? Neutron 4. Like that, you do the remaining also. Here atomic number 92. So proton 92, electron 92, neutron minus it and write 238 minus 92. Okay, then what are nucleons? How many nucleons are present in phosphorus? Draw its structure. Okay, the answer is here. Page number 128. The protons and neutrons are collectively called nucleons, are found in the nucleus of an atom. And for the phosphorus, you have to draw this diagram. Okay. Totally, how many nucleons are totally here? 15 plus 31. 31 nucleons totally present in phosphorus. Write the answer 31 and draw this structure. Okay, draw this structure for that. This is the first question. What conclusion were made from the observation of gold foil experiment? That is Rutherford model of atom. Then explain for that is Neil Bohr's model of atom. This question I did not take. So whatever have I given, you just learn for your exams. Okay. The next one, you just for the exam, if it is asked me, you should write no. So name of the element alone I am giving. First one fluorine, next one sulfur, magnesium, deuterium, hydrogen. Please copy done. Remaining you fill it of your own. So fluorine, sulfur, magnesium, deuterium, hydrogen. One you can see here. Atomic number 7. So atomic number 7 means proton 7, electron 7. Isn't it? Proton and electron 7. The remaining neutron is what? 10. Mass number is 19. Sorry. 9. Mass number is 9. It's not 19. The mass number is 9. Like this you have to fill this table. Name of the element I am giving. Fluorine, sulfur, magnesium. Remaining you do of your own. Book inside question, what is the atomic number and mass number? So here we write the symbol is that. Okay, atomic number means what? Number of protons is equal to number of electrons. Okay, then mass number, it is the mass of a particle of atom depend the total number of protons and neutrons present. This number is called as mass number. Mass number, atomic number. And how to represent? Just to go through this. Then study the problem for the exam. This is for one word. Okay, Z stands is one time it is asked for just Saal. Here Mazensaal in German. What is the symbol? Z and A stands for, so one word. The next one, valency. Valency of an element is the combining capacity of the element with other elements and is equal to number of elements that take part in chemical reaction. Very important question. Valency. This is the book inside question. The next one, isotopes. Here, two types of isotopes, stable and unstable isotopes. Which one? Okay, unstable isotopes are called as radioactive isotopes. Uranium-235, nuclear reactor, cobalt-60, radiotherapy treatment. One word you can learn. Here it is given. This is the example for hydrogen. Here isotopes, the example for hydrogen, 1H1, H2, H3. They have different mass number, same atomic number. Okay, here we can write which have same, which have same atomic number but different mass number is called as what? Isotopes. Atoms of some elements have been identified, which this one isotope. Next one, isobar. Atoms of different elements with a different atomic number which have mass number is known as isobar. Last one, isotones. From here, this is the example. These are the book inside important question that you have to learn. The next one, law of multiple proportion. Very important questions. Once it is asked for a annual exam. So this is multiple proportion. These are the questions can be asked for the coming exam. Students, So these are the evaluation part and book insert question that you have to learn for your coming exams. Okay. The next one, law of reciprocation. This is also you mark it. Next class I will explain you. The last one, Gay-Lucas law from here to here. This is the bigger from plus diagram. This is a Roman number 7, third question answer. Roman number 7, third question answer. State Gay-Lussac. So this is not for your exam, but you mark it. Again, I cannot repeat, no. So just you mark it. Okay, this is the answer. Okay, students, thanks for listening. So students, please learn, complete this lesson. This lesson is very important, okay? Atomic structure. Whatever, I hope I 2 question I did not give the answer for you. That later I will give it. These problems, I told you to do it, okay? Everything you write in the class of note. And the study portion is, this is the exam portion. So learn very well this lesson fully. Till just leave it today's portion. That is, no need to study laws of chemical combination. Before that, whatever I have completed, you just go through, okay? Neil Bohr's model, Rutherford model, what are nucleons, draw the structure of this proton phosphorus, the book insert question, isotope, isobor, isotones. These are the questions you should learn well, okay? And write the test, okay? Thank you so much.